So due to internal resistance of the cell, some of the voltage of the battery will be lost. In reality, what we do, if in your IGCSE we have done with the circuits, even here we will deal with the circuits. For example, if we are saying that one resistance is connected here, which is external resistance, it is R, and we are providing 5 volts from this. And if I connect voltmeter here, so previously we have studied this thing that obviously in parallel there will be 5 volts, which will be same here across this resistance because we are applying 5 voltage here. Okay, it's in your knowledge already. Okay, but in reality, when you will take the voltmeter reading, it will not be 5 volts, it can be 4.85 volts. So that
Into internal resistance.
0.15 volts are lost, and the reason is only internal resistance of the cell. As I've already mentioned you when we were doing PD or EMF, so actually voltage or EMF is something related to the energy. So actually energy would be lost due to internal resistance, and that would be equals to, for example, if I subtract it, so I can calculate lost volts. That can be EMF minus V, this voltmeter reading. Actually, this voltmeter is called terminal PD. This is called terminal PD in the language of circuits. So either you can connect voltmeter here, or you can connect voltmeter here, or either you can connect voltmeter here. So you will get the same voltage, which will be 4.85. The interesting thing is this, because we know that in parallel combination, voltage remains same. Okay. So I can just think in this way, just let me redraw the circuit. For example, if there are 2 wires here, maybe there are 2 copper wires here. These are conductors, conducting wires. At this point, I connected a battery of 5 volts between these 2 points. As it is a positive terminal, it's a negative terminal battery. So I can call this wire as a positive wire and this wire as a negative wire. Okay. Then I can connect a resistance here, suppose, between these 2 points on this wire. This is very interesting. Okay, so you can call these points as AB. You can call these points as CD on these railing wires. Now, for example, if suppose the length of the wire is very long, for example, or even at the bottom, I can extend it. So whatever you will connect between these 2 wires, you will get the same voltage. Do you agree? Because all would be in parallel combination. Do you agree or not? So it means if I'm saying that I want to connect voltmeter here to measure the PD between these 2 wires, any one is positive, one is, or I must use the word terminals. Why terminals? Because this wire is directly connected to the positive terminal of the cell, and this wire is connected to the negative terminal of the cell. So I can call these wires as terminals. So it means I can call this voltmeter reading as terminal PD. Can I say that it is terminal PD? Okay. If we are calling it terminal PD, so it means whenever there will be notation in our circuits, capital V, so it will be used as terminal PD, and this notation is for terminal PD. That's interesting. And in this formula, this is terminal PD. It's very dim. This is terminal PD. And here it is EMF. Okay. And now, for example, if I connect voltmeter here, so what do you expect? What reading should you get? Obviously, that should be same as
Is the same.
for example, if it is 4.85 volts, so here it should be 4.85 volts. Very simple. Even if you connect voltmeter here, so what reading you expect? 4.85 volts here. So that's why we call this V as terminal PD. And basically the potential difference between these 2 terminals, and that is always 4.85, and 0.15 are lost due to the internal structure of this cell, due to the internal resistance of this cell. So that's why we can develop an equation which is basically lost volts. So lost volts is equal to EMF minus terminal PD. Okay. Now by Ohm's law, can I write like this? Whatever is the volts, चाहे उस volts का जो भी नाम है, चाहे वो lost volts है, चाहे gained volts है, लेकिन जो भी lost volts या volts can be equal to current multiplied by resistance. So what is the resistance due to which volts were lost? कौन सी resistance जिससे volts lost हुए थे?
R. Cell
Capital R or
resistance.
small r? Cell resistance. Very good, Ali. So
Yes.
cell resistance का symbol क्या था? It was small r. So it means I can write either lost volts by I into small r, or you can write like this. It's the same thing. Okay, it's the same thing, by the way. So from here, if I equate these two equations, so I can I write like this: E minus V equals to IR. We can write this equation. Clear? E minus V equals to IR. And from here, you can calculate small r. It will be E minus V over capital I. Even you can calculate the internal resistance value by this formula. It's a direct formula to calculate internal resistance. Is it clear, students? If there is any confusion in it. Okay, you know, in physics, we do not rely on one single value because this is something which is not directly measurable. Small r, it is inside the cell. So to you can say to obtain an accurate reading, what we do, we always take few sets of readings and then we plot a graph. Okay, just to assure this thing that whatever we are calculating is the correct value. So finding internal resistance of a cell using graph. So this is my next topic, finding or calculating internal resistance of the cell using graph. Okay, let's do that. But for this, I need to make a circuit in which I need to use something which can give me 6 readings or several readings. For example, this is the symbol of internal resistance. To measure current, I can connect ammeter anywhere, maybe here, because meter is connected in series. So it doesn't matter the position of ammeter, it will give a same reading at all points. And a resistor here. And there should be a voltmeter across the resistance to measure the voltage. But even now, I can, if suppose if we switch on the circuit, I will get only one value. There is no such arrangement. There is no such setup by which I can change the readings, but I can get several readings or some sets of readings, you can say. So what should I do? I can just use a rheostat. Is it clear, students? Definitely, I need a few more readings so I can change the value of resistance and then I can measure current and voltage here. You can increase or decrease the resistance value. So vary R to vary I and V, very simple, and take 6 sets of readings at least. Is it clear? 6 values दे देते हैं. For example, if continue slowly, gradually, I am increasing R value and I'm getting 6 sets of readings. And we are not supposed to write the readings here. We just want to get an idea that how we can take 6 sets of readings. Okay. So from here, I can, since, if you remember, since lost volts formula was E minus V, and in fact, lost volts formula was also I into R. So I can equate these two. So it means I can say that E minus V equals to IR. I've already done this step before. I'm just repeating that step. Okay, now by Ohm's law, can I write capital V as I into R, capital R, because it was PD cross this resistance. So I can write like this. Is it clear, students? But I don't want to write here because I need to, I'm sorry, I need to draw graph between voltage and current. So I can make voltage as subject of the formula and take IR on the other side. So take V on this side and IR on the other side. So it would be minus IR plus E. Can I write like this? So this will be the way by which we can do it. And then just rearrange this position. I can just write R into I plus E. Why I want to do this? 2 into 3 or 3 into 2 are the same thing, no? In multiplication, both will give you 6. So it doesn't matter if you change the order in multiplication. So I into R or R into I is the same thing. Why I'm writing it, it will be clear in 1 minute. So I just want to compare it with this equation, y is equals to mx plus c. Many of you are taking maths. You know that this is a straight line equation because I want to plot a graph. So according to this comparison, this v should be taken along y-axis. I should be taken along x-axis. So this will give you can say, gradient. And gradient will be equals to minus r. Do you agree? And here, this can be the y-intercept because c is y-intercept. So just write this one as gradient. This is gradient, and this is y-intercept. Okay, what will be the shape of the graph? Can anyone suggest what should be the shape of the graph?
Straight line cutting through y-axis.
Straight line going down or up?
It will go down because the gradient is negative.
Gradient is negative, very good. So it should be a straight line. For example, this is voltage axis and this is current axis. So it should be a straight line going downward because it's a negative gradient. So roughly, I can just draw from here to here, just like this. So this will be the y-intercept, and I can find out the gradient by choosing 2 points. You can just make a triangle here. So this will give you delta V, this will give you delta E. So gradient of the graph is minus R. It means R is minus gradient. Can I write like this? So it means first calculate the gradient of the graph and then multiply it by the negative sign. So you will get the internal resistance of the cell. And similarly, y-intercept is EMF. So it means just to find out the EMF, I can write in this way as a formula. It means EMF is equal to y-intercept, whatever is the y-intercept. So I can label this point as EMF. Okay. Is it clear, students? Is there any confusion? So please tell me if there is any confusion. So please keep
I have
these.
one question.
Yes.
So in the graph, the point between the distance between E and origin, can that also be called delta V?
Okay, this one, distance E and origin.
Yes. Is it delta V also? the triangle?
Uh, but it will be the maximum. Yes, you can find the gradient. No problem. Then you need to take this one from between this and zero current. I mean zero potential. It
Okay.
will be a larger triangle. Yes, you can get your answer. You will find the gradient even then. Okay. But it is
Yes.
better to show the triangle in the graph if they give you such questions.
Yes.
So this would be one way by which you can do, I mean, using graph, you can find out the internal resistance of the cell. I hope it is clear. If there is any confusion, so please ask me because I need to do something, some question, then I need to explain you the maximum power output of the resistance. Just a minute. Let me use some questions. I'm sorry, please wait for 1 minute. I'm just finding out some of the questions because they always mix up the questions, no? Separately, there was one question I was just finding out that it was always चला गया. Hmm. Okay, this is a question. You can see it's a 10 marks. A battery of EMF E and internal resistance R is connected to a variable resistance of R as shown in the figure. This is the setup which I just explained you. The current in the circuit is I and the PD across the variable resistor is V. Okay. Explain in terms of energy why V is less than E. Yes, in terms of energy, they're asking. Energy is lost
Some
due to
energy is lost due to the cell resistance.
internal resistance. The cell resistance, internal resistance of the cell. Very good. State an equation relating E, I, R, and V.
Yes, sir. Is E minus B
Is equal to IR. You can just write like this. Okay. Or you can write in this way E minus V
yes, sir.
over I equals to R.
So R is equals to E minus.
Just like this. Okay. So whatever the way you can write it in this way. Now they have given the graph. The resistance R of the variable resistor is varied. The ratio with I of V is shown in the figure. Okay. Explain how it may be deduced that EMF of the battery is 2.8 volts. जी आप लोग बताएं आंसर मैं एक छोटी सी कॉल अटेंड कर रहा हूँ सॉरी ओके आप लोग आंसर बताएं हेलो वीडियो वालेकुम सलाम जी अलहमदुलिल्लाह Sorry, Ji, there was call. Yes, you're right that y-intercept is 2.8, so 2.8 volts. So by finding the y-intercept. Okay, then further, y-intercept is 2.8. Calculate the internal resistance R. So how you can do it?
We use a formula
तो
RG.
1.47 हो रहा है.
They have mentioned use figure 6.2.
Oh, then we can find the gradient.
Gradient. You can choose this point and
-1.
this point. और this point में भी कोई आसान ले लो point जो कि आसान कोई भी नहीं है यही लेना पड़ेगा. So you can draw a line.
One we already know.
Yeah, this is 2.8.
2.8
And what
and
is
0.
this? 1, 2 boxes.
1.7.
So each box is representing 0.1, I think.
1.7.
So it is 0.7.
Oh, yeah, sorry, 0.
So along y-axis, we have 2.8 minus 0.7 divided by, along x-axis, you have 1.5 minus 0.
0. 1.5.
So what would be answer?
1.9 divided by 1.5. Let me calculate.
It's not 1.9, it's
2.1.
1.1 divided by 1.5.
The 2.1, it's 1.
2.1.
Answer is 1.4.
Okay. So 2.1 divided by 1.5 is answer is 1.4.
Yes.
Okay, so 1.4 ohm is resistance. The battery stores 9.2 kilojoules of energy. The variable resistance is adjusted that voltage is 2.1 volts. Okay. Use figure 6.2 to calculate the capital R. So capital R कैसे find करें? You need to use this figure. Simply find out the voltage divided by current. What was voltage is 0.7 and current is 1.5. So can I do it? R equals to V over I.
Someone's saying he can't hear you.
Sorry,
Someone said he cannot hear you.
who said? I can't hear. Why you can't hear? I didn't mute anyone.
लगता है इसको भी किक करना पड़ेगा.
क्या करना पड़ेगा?
किक करके फिर से निकालना पड़ेगा. ना लिख बना के.
अब ठीक है अली आपको अब ख्वाजा अली अब ठीक है प्लीज चैट ये जूम बिल्कुल भी फजूल है वैसे एनीवेज इसको प्लीज सॉल्व करके देखें 0.7 डिवाइड बाय 1.5 कितना आता है
So it is 0.47. 0.47.
तो वोल्टेज तो हमें 2.1 लेनी पड़ेगी ना.
जी 2.1 नहीं ली मैंने
0.7.
So he took the lower one.
2.1 पे लिख देखना पड़ेगा सॉरी यू आर राइट
I think the ratio is same, so answer should be same.
लेट मी चेक द आंसर ना अभी पता चल जाता है टू पॉइंट वन पे देखनी पड़ेगी क्या है इसकी वोल्टेज कैन समवन सी फ्रॉम द ग्राफ 2.1 पर 2.1 इज हियर समवेयर एंड
2.1 is, yes.
0.5 so 2.1 divided by 0.5
4.2.
2.1 divided by 0.5
4.2. 4.2.
yes this
Value
is
gets
correct
double.
this is correct calculate the number of conduction electrons moving through the battery in a time of 1 seconds अब कैसे करें जी
Electron.
yes number of conduction electrons Q equals to N ही होता है ना
Yes, sir. This formula.
So you need to find Q first. Current वगैरह दिया है इसने कहीं पे?
They gave, I think they gave current. You can find the current using values. V is equals to I.
But it's a 1 mark only. करंट आप डायरेक्ट निकाल सकते हैं ना. I'm sorry, देखे ना इस पे 2.1 वोल्ट पे कह रहे हैं ना वो. 2.1 वोल्ट पे करंट क्या आया था अभी आपने देखा?
0.5 था मेरे ख्याल में.
0.5. So just use time उसने दिया 1 seconds. So I equals to Q by T. So from
Sir,
here
direct
Q
0.5.
0.5 ही आ जाएगा direct. You're right. 0.5 multiplied by 1. I'm just trying to show you working. Otherwise there is no need. So 0.5 coulomb. So just use 0.5 equals to NE. Then what will be N? E by 0.5.
The constant they gave us.
So it can be E by 2, E multiplied by 2, NE 1.6 into 10 to the power minus 19 multiplied by 2. So it is 3.2 into 10 to the power minus 19 electrons. Okay. 3.
सर गलत नहीं हो गया?
क्यों?
सर 0.5 डिवाइड बाय ई होना चाहिए ना?
और 0.5.
मैं भी ये सोच रहा हूँ 0.5 divided by
0.5 over the you are right. Sorry. क्या हो गया मैथ्स का? It should be 0.5 divided by E, and E 0.5 multiplied over 1.6 into 10 to the power minus 19. क्या आता है आंसर?
I'm calculating.
3.125 times 10 to the minus 20.
Okay.
Can you please speak slowly? I can't hear.
Sir, 3.125 times 10 to the power minus 20.
माइनस नहीं हो सकता यहाँ पे कभी भी.
सर यही आ रहा है सर 0.5 डिवाइड बाय 1.6.
नहीं माइनस नहीं हो सकता बेटा, दोबारा से चेक करें. पावर माइनस नहीं हो सकती.
सर यही आ रहा है.
कोई और कैलकुलेट कर ले प्लीज.
10 raised to power 18 आ रहा है पॉजिटिविटी.
Positivity. So 3.1 into इसको you can write 3.1 into 10 to the power 18 electrons. Okay. This can be the answer. Yes, it is correct. And then the next part, determine the time taken for the energy in the battery to become equal to 1.6 kilojoules. Assume that the EMF of the battery and the current in the battery remain constant. So, we know the energy formula. Energy formula is VIT. But they are saying that energy is decreased. So E2 minus E1, I can use two energies equals to voltage into current into time. Okay. Voltage into current into time. Just take the difference of energies. Energies the difference later. And on the right side, you can use voltage into current into time. What was voltage? E2 कितनी इसने पहले कितनी दी थी? 9.2 kilojoules. You can see this. 9.2
Energy or
minus
volt?
1.6. This is energy. Energy is equals to VIT. Okay. Into 10 to the power 3 common ले लें इसमें से because ये किलो था ना. Equals to voltage कितनी है जी?
2.1.
2.8 volts. They are talking about the battery. EMF of the battery लेनी है ना अपने यहाँ पे. Because this is energy in the battery they are asking. You can see here in the battery. Okay. So
Okay.
it should be 2.8. Multiply by current is 0.5 and time you need to find. So 9.2 minus 1.6 कितना होता है जी?
It's 7.6.
Divided by 2.8 into 0.5.
This should be 1.4.
Answer is 1.4.
Oh, not 1.
Sir,
1 second, sir.
5,400 seconds.
How much, Ali Beg?
5,400 seconds.
5,400 seconds. Yes.
5,429 to be exact.
Yes, it's correct. 5,400 seconds is correct. Okay, so you can see that what is the way by which they ask questions from the same topic, internal resistance of the cell. Okay, was it
Yes.
difficult?
Not difficult, but it is not the most easy either.
No, it is not difficult after understanding the concept. If concept is clear, then there is nothing which is difficult.
सर एक क्वेश्चन है वो मैं अटेंशन मेरी कहीं डाइवर्ट हो गई थी ये थ्री कहाँ से लाया हम ये थ्री क्या है यहाँ पे
Which three?
9.2 minus 1.6 into 3
10 to the power 3 है ये बेटा.
अच्छा अच्छा
It's 10 to the power 3 because it was kilo na. Kilo ka 3 है and even 9.2 was also kilo. Kilojoules. You need to convert it into joules. So kilojoules to joules you need to multiply by 1000. Okay.
ठीक है
Is it clear?